going to do lesson 3 in the first unit of geometry, and this is going to be different forms of lines and figuring out if they're parallel, intersecting, perpendicular, all sorts of fun stuff. So starting off, it's important to know that the equation of a line can be written in many, many different forms, and so being able to manipulate equations will help you make better sense of what you're actually looking at. So our two most common is point slope and slope intercept forms, but these are equivalent. So anytime lines are written in different forms, they are still equal to each other. And then with vertical lines, since their slope is undefined, we cannot use point slope form or slope intercept forms for a vertical line. So starting off, we have point slope form of a line. So the point slope form of a line is y minus y1, which is equal to m minus x1. And you notice, and I'm actually going to change this to yellow so it's a little bit less intrusive of the colors that are there. But the m is your slope, and the x1, y1 is a given point. So let's just say we knew the slope was 1/2, and we had a point at, let's say, 2, -4. Then you would have y minus -4 equals 1/2 x minus 2. So it's important to note that this 2 comes from the x. So if it's an x value, it's going to be with the x, and if it's a y value, it'll be with the y. Now, over on the left, because we have this y minus -4, that does become a plus. So just something to keep in mind, your signs are opposite for these. And signs are opposite. Guess I could put ordered pair signs. All right, so then we have a slope-intercept form, and that's probably the one most people are most familiar with. But slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. M is slope, b y-intercept. So let's say we knew that our slope was 1/2, and our y-intercept, let's say, is -2. Then we would have y equals 1/2 x minus 2. So this one, signs stay the same. All right, so then with a vertical line, that brings in vux. So remember, vertical, undefined slope, x equals something for the equation. So since it's a vertical line, you'll have something like x equals 4, for example. And with a vertical line, you'd have something like y equals 3, and that's the HOI. So horizontal, 0 slope, y equals something for the equation. All right, so if I wanted to write the equation of a line in point slope form, and I'm given the slope and a point, I don't need any extra information. So I have y minus y1 equals, not x, whoopsie, erase, m times x minus x1. So we know what the y1 is. It comes from the ordered pair. So we have y minus -4 equals slope, which is 6, and x minus the x value. And so because it's y minus -4, that does become a positive, and so then you are left with y plus 4 equals 6 times x minus 3. And even though it may be tempting for you to put it into slope-intercept form, because he asked for point slope form, just leave it in that form. So then I have a line that goes to the points -1, 0 and 1, 2, and we want it in slope-intercept form. So since it's slope-intercept form, I know I'm going to have y equals mx plus b, but I don't know my slope and I don't know my y-intercept. So first I'm going to find my slope. So that would be 2 minus 0 over 1 minus -1. And so that becomes a big fat positive. So we have 2 over 2, and 2 divided by 2 is 1. So that means that in this equation, I can now replace this m with a 1. Okay, so then to get my b, I am going to use y equals mx plus b, but instead of x and y, I'm going to plug in one of these ordered pairs that I'm given. So personally, this one, it doesn't really matter. I'll just go and use the -1, 0. So since it's -1, 0, the -1 is going to go where the x was. And then the y is going to go where the y was. So then you're just going to solve this equation for b. So that gives us -1 plus b. We add the 1 to both sides, and we get b is 1. So if I get my b is 1, then I have the information I need. I have my y-intercept, and I have my slope. So then to write this in slope-intercept form, it's going to be y equals x plus 1. And that x plus 1 comes from our slope and y-intercept. And the slope, we just don't write that 1 there. Okay? All right. So moving on, let me draw a little line so I don't mix up my work. Okay, so if I want to graph the line y equals 1/2 x plus 1, this is slope-intercept form, so I know that 1/2 is my slope and 1 is my y-intercept. So I'm going to start by plotting the y-intercept at +1. And then from that point, I'm going to go up 1 and over 2 because it's rise over run for the slope. So we rise 1 and run 2. And then you connect your dots. Okay. So for a point slope form, if I want to graph the line, I'm going to have to be able to identify the slope and then the point they gave me. So looking at this equation, I know my slope is -2. And then my point is going to be based off of this 4 and this -3. But remember, with point slope form, it's opposite numbers. So because we start with our x value, we're going to start with that +4, but the opposite is -4. And then with the y, it looks like a -3, but it's really going to be a +3. So then we plot that point, -4, 1, 2, 3, 4, and up 3. And then a slope of -2 would go down 2 and right 1, or up 2 and left 1. Then you connect your dots, and that's all you have to do. All right, so then if I want to graph the line y equals -4, again, hoi vux, it's a y equals, which tells me my slope is 0, and then I know it's a horizontal line. So at -4, 1, 2, 3, 4, I'm going to put a point, and I'm going to draw my line, like so. Yay! But for vux, we have an x equals -2. So -2 on the x-axis. And then my slope is undefined. And then it is a vertical line. That's what the V is for. So we just connect like that. All right. So lines that coincide are the same line. But the equations may be written in different forms. So when it's coinciding, they should have the same slope and the same b or y-intercept. So lines have a few options, and you can actually ignore this none of the above because that only applies when you have multiple planes, and we are not going to be addressing that issue yet. But lines can be parallel, perpendicular, coinciding, or intersecting. Okay, so a system of two equations and two variables represents two different lines. So starting with parallel lines, what you really want to look for is the same slope. So notice 5 and 5, they have the same slope. They should have a different y-intercept though, because if they have the same y-intercept, then it's going to become a coinciding line. So then for intersecting lines, you just need different slopes. And it doesn't matter what the y-intercepts are, the slopes just have to be different. For coinciding, you need the same slope and the same y-intercept. And actually, it's important to make sure you're looking at the signs as well. And then for perpendicular lines, it's opposite reciprocal slopes. So if I had, let's say, y equals 2x plus 1, then a perpendicular line would be y equals negative 1/2 x. And it doesn't matter what the y-intercept was. So if you want to make a note, y-intercept can be the same, but not always. Okay. All right. And same thing over here as well. Y-intercepts can be the same, doesn't matter, but it's not always going to be the same. Okay, so now we want to figure out if the lines are parallel, perpendicular, or intersecting, or coinciding. So starting off with A, we compare the slopes. We have 3 and -3. So because these are not the same slope and they're not opposite reciprocal slopes, that tells me that these are just intersecting. And it's because of different slopes. And you do not have to tell me why every single time, but it might not be a bad idea just when you're beginning to force yourself to think about why. So then for B, we have some that are in two different forms. So we have to rearrange this so that it is in the same form. So since this one on the left is solved for y, I'm just going to solve for the one on the right for y by dividing by 6. And you have to remember to divide everything on the right side by 6. So 2 over 6 becomes -1/3 x, and then 12 divided by 6 is 2. So you notice with these, they share a slope. And so because they have the same slope and a different y-intercept, that tells us that these are parallel lines. Okay. So then for C, we are going to have to rearrange again. Notice they're in different forms. So what I would probably do is try and make the one on the right look like the one on the left. So because I have a y minus 3, actually, you know what? Let's just make it slope-intercept form because point-slope form has a tendency to mess people up. So when we add 3, that gives us y equals -1/2 x plus 3. Okay, so then we'll just do a lighter pink for this one. Yes, that might be too similar. Let's do purple. Actually, we'll do orange. I can't decide. So we're going to distribute the 2. So we have y minus 5 equals 2x plus 6. And then we're going to add the 5 so that we have y equals 2x plus 11. Now with this, you notice our slopes. They are opposite reciprocals because they are opposite signs, and it is flipped. So because of that, these are perpendicular. Okay. So then, last but not least, we have these last two equations. So again, trying to make them look similar. Since the one on the left is just 2y, I know that if I'm able to make the one on the right equal to 2y, I'll be able to compare them. So I am going to start by subtracting 4x on the right side, because then I end up with -2y equals -4x plus 8. Well, because I want to get it to just be a 2y, I'm just going to divide by -1. And by the way, you are free to divide both of these by 2. That way you have just a y equals something. But when you do that, that gives us positive 4x and -8. And you notice these two equations are exactly the same. So because of that, I know that these are coinciding. Okay, so the homework is 3.6. which I do not have the page number off the top of my head, but that would be chapter 3, section 6 in the book. So if you have any questions, feel free to ask. If this video was helpful for you, click the little like button or subscribe as more videos come out, and we will see you later.